All this room for activities. So now let's go back, make sure we're all on the same page. We have a decrease in blood pressure. Our juxtaglomerular apparatus recognized that with the granular cells, released renin. Renin converted angiotensinogen into angiotensin 1. We went up to the lungs, angiotensin converting enzyme gets you to angiotensin 2. So that's where we're at now, is what does angiotensin 2 do? All right, so there's a lot of different things that it's going to go communicate to. I think one of the best ways to kind of keep track of this is really kind of keep track of its variety of targets. And so let's start with coming down and talking to our afferent arteriole. Remember, the goal of this, and I guess if you want to keep this in track, is to increase blood pressure. So at the afferent arteriole, if you want to increase your blood pressure, you want to do stuff that gets the kidney to stop losing as much water. You want to increase your water volume. So what we're going to do with that afferent arteriole, we're going to constrict it. If we constrict the amount going into the glomerulus, we're getting less sample. We're lowering our glomerular hydrostatic pressure. So we're going to constrict. That lowers your glomerular hydrostatic pressure, which therefore lowers your glomerular filtration rate. Does that make sense? You have less getting filtered because you have less going in. And if you have less getting filtered, you have less water getting lost in urine. So then you're going to decrease water loss, which another way to word that is increase water in blood. Okay. Another thing that we could do to change or affect that glomerular hydrostatic pressure and glomerular filtration rate is change the size of the filtering holes. Remember, the glomerulus is a fenestrated capillary. It has holes in it. You can control how open they are by opening and closing them through mesangial cells. And again, you're going to contract them. If you contract these, you're decreasing the size of the holes for filtration. So you're decreasing your filtration slit space. So you're decreasing filtering openings. So decreasing the pores, the fenestrae, and decreasing the gap or space for your filtration slits. That means you're going to drop GFR as well. And these are the same, which means you're going to end up with the same three things, right? So you're going to end up with less water loss, which means more water in blood. You'll also use angiotensinogen to talk to some other endocrine structures, like the posterior pituitary. Posterior pituitary releases ADH. The job of antidiuretic hormone is to increase water reabsorption. So that's actually going to go to distal convoluted tubule and collecting system. Job there, increase reabsorption. You're putting pores in for water and telling your body, no, we do need to keep this, don't lose it as part of your urine. So again, we are decreasing water loss, which increases the amount of water in blood. So we're getting that these are the same so far. Now we're also going to talk to the adrenal cortex. Adrenal cortex is going to release something that also affects the DCT and collecting system. If you can think back to studying endocrine system, it releases aldosterone. Aldosterone gets us to increase, I guess I should have been specific over here. ADH gets us to increase reabsorption of water. Here we're going to increase reabsorption of sodium. But that has the same effect here. If you're increasing the amount of water or the amount of salt that you're putting back into your body, water is going to follow that. So we're going to have an increased reabsorption of sodium that makes our blood have an increase in hydrostatic pressure. Sorry, That makes our blood have an increase in osmotic pressure. That's going to allow us to suck water back in, also lowering your glomerular filtration rate. Because if you remember, glomerular filtration rate, you have hydrostatic pressure pushing you out, but you also have an osmotic pressure sucking you back in. So you're going to increase reabsorption of water even more if you're bringing in salt. Water follows salt. So we have the same things happening here. We're going to increase our amount of sodium coming in. That will increase the amount of water you bring back in. So you're going to lower your water loss, which increases the amount of water in blood. But wait, there's more. So now we're going to go hypothalamus. Hypothalamus has our thirst center. Job there is you're going to activate the thirst center. To then increase water acquirement. So you're going to go get water. And then we'll absorb it. So increase water absorption. Remember, this is different than over here. So absorption, first time it's coming in, you're using the digestive tract. So we're going to increase water absorption, bringing it in through the digestive tract because you went and consumed it. But again, that's increasing the amount of water in blood. I'm just going to actually do this. These are all the same thing. So increase water in blood. Okay. So far we have now 1, 2, 3, 4, 5 different plans for increasing the amount of water in blood. Afferent arterioles, constricting, so you're getting less filtered, less put into your sample. Mesangial cells, constricting, less filtered, less gets put into, gets lost from blood. Our posterior pituitary adrenal cortex releases some hormones that basically tell our kidneys to reabsorb water and reabsorb salt. So that way they kind of help each other out. The more salt you reabsorb, the more water you'll reabsorb as well. Hypothalamus, this one's a little bit different, but same end goal. You end up with more water in blood. This is because we've activated the thirst center and we went out and got some more water. All right, so all of that is about increasing the amount of water, which realistically, all of that bubbles down to increasing blood volume. Okay, there's one final effector for our angiotensin II, and that's blood vessels as a whole, not just this one. It'll be the same effect though. It's going to cause constriction. If you're constricting blood vessels, you're increasing your total peripheral resistance. And don't forget, that basically means if you're increasing peripheral resistance, you're causing an increase in pressure directly to that blood vessel. So this one right here is your one that's actually going to directly affect your blood pressure in the way that we talked about with cardiovascular system. Because all the way back in the beginning of the semester, we talked about our blood pressure being controlled by your cardiac output and your total peripheral resistance. This is really kind of dealing with this and something we hadn't really focused on before, which is water volume. So this is the new part of the story. You will still do things with the cardiovascular system. That's not part of the story. We're focusing on that interplay between our endocrine system and our kidneys and what the kidneys are up to. But you are at the same time that you're doing all of this increasing your heart rate and contraction force as well because you've activated your sympathetic nervous system. So a lot kind of going on here. So increasing blood volume, squeeze the blood vessels, those will increase blood pressure. Now, if you have the opposite problem, you just inhibit all of this. So if you have a problem where you have an increase in blood, then you're going to use receptors in the atrium and they're going to release atrial natriuretic peptide. The job of ANP is basically do the opposite of all of this. So instead of constricting, you're going to dilate. Instead of contracting the mesangial cells, you relax them. You will turn this off, you will turn this off. So you're going to inhibit here. You'll turn this off. Again, another inhibit. And then over here, instead of constriction, you'll dilate. Basically, the overall job of A&P is to lower blood volume by doing the opposite of everything we saw here. So if you dilate, that means you're going to filter more, means more gets lost in blood, or more gets lost from blood and ends up in urine, more water specifically. If we relax the mesangial cells, those pores get bigger, you have more getting filtered. You have more water being lost as part of urine, less staying behind in blood. Over here, you're turning off the system that tells you to reabsorb. So anything that makes it to the end of the nephron is just going to stay there, and it's going to be part of your urine. We come over here to the hypothalamus, turn off the thirst center. So this is going to then allow us to kind of get rid of the extra volume that we have through urination and not add to it. And then over here, dilate those blood vessels to increase the size of the lumen and then lower that total peripheral resistance. So A&P just doing the opposite of everything you've had down before. So that's really what's nice about a negative feedback loop. Once you understand one side, the other side just kind of flip it and do the opposite. All right, I know that was a lot. Thanks for sticking through it, the whole thing.